Okay, so we're going to solve simple trig equations. And what's slightly different from what you learned at GCSE when you're solving trig equations is we're going to have solutions over a certain range, over a given range. So hit pause, copy the lesson objective now. When you're ready, hit play again and we'll look at an example. So we're looking at this example here, and we've got to solve the equation sine theta equals 0.5. Don't need that yet. In the interval from 0 to 360. So we're trying to solve this equation from 0 to 360. Okay, so if we look at our graph there, so we're starting from 0 all the way to 360 there. Remember, we've got a maximum value of 1 or positive 1 and a minimum value of negative 1. Okay, so we have sine theta is equal to 0.5, which means theta is going to be equal to the inverse of sine to the minus 1 of 0.5. Now I know you remember the exact solution, but you can plug that into a calculator and it'll give you 30 degrees, which is fine. That's a solution, but that's not the only solution. Now if we come to our graph here, 0.5 is halfway, so it will be approximately there. And if we draw a line across to see where 0.5 intersects our curve, it does so at 2 points, there and there, which means we have two solutions. That's our 30 degrees. Let's just label that 0.5. That's our 30-degree solution. But there's also a solution here. Now the graph of sine theta is symmetrical. So the distance from here to here, which is 30, is going to be the same distance from here to here. If that's 180, that's going to be 180 take away 30, which is 150. So we've got two solutions. So theta is going to be equal to 30 and 150. There are no other solutions for 0.5 between 0 and 360. If we had to extend the curve, then we would have other solutions if they said it was beyond 360. Okay, but we're going just for the interval that we've been given. Okay, so hit pause, write the example down, make sure you sketch the curve and sketch where 0.5 intersects. I'm sure you'll do a better graph than mine. When you're ready, hit play again, we'll look at another example. Okay, so let's have a look at the second example. It says here, solve the equation 5 sine theta equals minus 2 in the interval of 0 to 360 degrees. So similar to before. So let's have a look then. Well, first things first, see if we can find what theta is as an angle. Okay, so we won't need that quite yet. You've got 5 sine theta equals minus 2. That means sine of theta is equal to minus 2 divided by 5. It's times on this side is divided on this side. So theta is equal to sine to the minus 1 of minus 2 over 5. And you need to plug that into your calculator, and it gives you an answer which is minus 23.6. Okay, so theta equals minus 23.6. In order to solve that, I'm actually going to sketch my own curve this time, see what happens. Not the best on this board. Okay, 180, 360, but I've got a minus 23.6, so I'm going to go backwards a bit. That's minus 180. Right, so minus 2 over 5 is the same thing as minus 0.4. Sorry, minus 1 here, a positive 1 here is maximum. So it's going to be somewhere around here is where my line intersects. Let's just draw the line. So I've got a solution there. I've got another solution there, another solution there. The interval they've given me is 0 to 360. So it starts here up to here. So the solutions I'm looking for are these two. This solution that I found, which is 23.6, sorry, minus 23.6, doesn't really count. But how can I find these angles here? Well, symmetry again. That's 23.6 away from the origin there. So this point here is going to be 23.6 added onto 180. So I've got theta equals that. Another angle is 180 plus 23.6, which gives me this one here. And then I've got this one here, by symmetry, is 23.6 away from 360. So 360 minus 23.6. So that gives us two extra angles. This is 203.6 and 336.4. And those are my two solutions. I can discard this one because it's outside the range. The range is from 0 to 360. This is outside the range, so I don't need this result. Just these ones that fit in. Okay, so hit pause. Copy the example down. When you're ready, hit play again. And we'll look at one more example. Okay, one more example. In this example, we've got, what do we got? Solve the equation of sine theta equals 2 cos theta in the interval from 0 to 360. So we've got the same interval, but sine theta equals 2 cos theta. Let's write that out. Cos theta. How can I solve this then? I'm trying. I remember an identity. Tan of theta is equal to sine of theta over cos of theta. That's going to work for me here. So if I divide by cos theta, both sides, I get sine of theta divided by cos theta. It's equal to 2. Sine over cos is tan theta. Now I can work out what theta is. Theta is going to be equal to tan, the inverse of tan, times to the minus 1 of 2. I worked that on my calculator and it tells me that it is 63.4 degrees. Okay, but is that the only solution between 0 and 360? I don't know. So I'm going to sketch my curve as best I can here. Okay, so tan curve. It's a strange one to sketch, and you'll see in a second why we don't sketch it so much. So it's asymptotic and it's unbounded, so it goes up to infinity, towards infinity. That's 90. Sketch it again. That's 180. And the asymptote, which it tends towards, that's at 270. And we sketch again. And that's 360. So that's a job done. Good. That wasn't too bad. Like I say, it's unbounded, so we can't just put 1 and minus 1 there. In this case, we could put 1 here and 2, which we need. Minus 1 there, minus 2. And because our solution was a 2 for 63.4 degrees, let's sketch a line and see where it intersects our curve. Intersects it there. That's that first solution. That's the one we've just got. That is, let's write it in red so we can see the difference then. So that one is 63.4. It intersects it here again. And this is why we don't tend to draw the tan curve very much. Because it repeats at 180, you just need to add 180. So this is going to repeat at 180 and 180 and so on. So our additional solutions, I'm going to go back to blue. It's just one more solution. Is at 180 plus 63.4. So those are our two solutions. So that's going to be equal to 63.4. And when I work that out, I should have 243.4. I should have done that in red. But yep, so that's our solutions in the range of 0 to 360. And it ends there. I'm going to change back to red again. So we don't need to go beyond 360 because that's all we've been asked to do, from 0 to 360 in the red interval there. Okay, so hit pause, copy our notes down. Once you're done, hit play again, and I've got a couple of questions for you to attempt. Okay, so we're looking at exercise 10D. It's very similar to the one we just done. Tan x equals -2. So questions 1 and 2. On question 3, I don't think you can just go down the left hand side because it's too many signs, and because it's so new, I would say you need to do a sine, tan and a cos. So ABC. After that you could do D and G and then move on. For 4, I'd say do the same thing, ABC and then maybe E. 5, A, C, D, and then 6 down the left hand side, back to normal then. Okay, good.